So today we're going to talk about how the inverse of exponential functions, which turns out to be a log. So if we were to fill out this table, and we have a graph of 2 to the x right here, some coordinates are, let's see, we have -1 and 0.5, 0 and 1, 1 and 2, 2 and 4, 3 and 8. So we know our definition of inverses, we switch the x and y. So if we go over here, this would be x equals 2 to the y power. Well, how do you solve for y? Well, we can't because it's in our exponent, so I can turn this into a log. So this would be log base 2 of x equals y. So that is our inverse function. I'll switch it to the inverse notation. So if they're inverses of each other, we switch the x and y. So this would be 0.5 and -1, 1 and 0, 2 and 1, 4 and 2, and 8 and 3. So 0.5 and -1, 1 and 0, 2 and 1. Oh, shoot, I got to check the scale on here. Let's double check that. Okay, so -0.5 would be here, and -1 would be here. 1 and 0 would be right here. 2 and 1. Let's see, 2, 3, 4, and 2. So this is going to be like that. Because again, if you remember, inverses of each other, see if are over the line, y equals x. They're a reflection, so then this would shoot down. So, a couple big ideas. The graphs are reflections over the line y equals x. They're inverses of each other. Where you noticed an exponential had an asymptote of y equals 0, the asymptote for the log is x equals 0. Sorry, I did this one wrong. 0.5 and -1, so it should be going right down here. I apologize, you guys. I was thinking this graph looked kind of weird. So it's going like this. That looks right. So again, and we could write our limit notations here. For exponential, the limit of f of x is x goes to -infinity. The limit of f of x is x goes to +infinity. Well, our limit, it goes to 0. It's leveling off at 0. At here, it's infinity. And for our log one, let's see, the limit of f of x, and this would be as x goes to 0 from the right-hand side, because again, it doesn't go to -infinity, so as it goes to 0, it goes to -infinity, and the limit of f of x is x goes to +infinity. It keeps getting higher and higher, so it would be +infinity. The domain of the exponential function is the range of the log function. So if I was to make if we use those up here, so if we had f of x and g of x, and our domain and range, so our domain is -infinity to +infinity with parentheses, so that becomes our range, -infinity to +infinity, and our range for our original was 0 to infinity, 0 in parentheses, so that is our domain from 0 to infinity. So we can see that they flip-flop. Now, operations, they also undo each other. So similar to like multiplying and dividing, a log undoes an exponent undoes a log. And we could see that up here. If it was an exponent, we could undo it with this log. And as a reminder, if they're composition of functions, if it is an inverse, we can do the composition as it equals x. So how do we tell if something is exponential or logarithmic? So if we look here, if we look at our output values, they're going up by 3. So this has to be exponential. Well, what happens for if on our inverse. Okay, so we got 1/3 and -1, 1 and 0, 3 and 1, 9 and 2, 27 and 3. So now it's the opposite. Our x values are multiples of 3. So when the x values are proportional, then it's logarithmic. So like, look here, we can see our y values are going up, not even evenly here, but that's okay. But what's happening to our x values? Our x values are going up by 4, multiples of 4, so it's logarithmic. Because if we switch those, -1, 1/4, 1, 0, 0, 1, 1, 4, 2, 16, 4, 64, we can see that now it's exponential because we're multiplying by 4. Now, as a reminder, inverses undo each other. So kind of like if we had 2 times x equals 4, to undo it, we divide by 2. So for example, if we had 2 to the x, and we also had log base 2 of the x, they would undo each other. So if I was to say, I want to get that x by itself, to undo it, I could add a log of this base. So if I added log base 2 of 2 to the x, that undoes it and it solves for x. So the bases are the same, so that just equals x. And it's the same thing over here. If I had log base 2, and if I raised it to a power, so if I did 2 to the power of log base 2 of x, it undoes that, and it is equal to just x. All right, so I think we're going to skip that next part because we already talked about how those are inverses of each other. So let's say we had something and we wanted to solve for 2 to the x equals 18. So one way to get that x out is we could log each side base 2. So since it undoes each other, I could log base 2 of 2 to the x. And then over here, it equals, and I could log base 2 on this side. Since it undoes each other, that would reduce out, and we'd have x equals whatever log base 2 of 18 is. All right, so our next thing, let's see if we need to find an inverse. So what if I had f of x equals 3 log base 5 of x? So the first thing to do to find an inverse is we switch the x and y. Okay, so x equals 3 log base 5 of x. Well, now we need to get the x by itself, so divide by 3. So I have x over 3 equals log base 5 of x. And how do we undo that? Well, if it's base 5, so undo it, we could do it to a power. So I could now say 5 to the power of x divided by 3 equals 5 to the power of log base 5 of x, and since it undoes each other, it would just be 5 to the x over 3 equals x, equals y. Sorry, this should have been a y, my bad. So that is our y. So let's take a look at another, and hopefully I won't mess this one up. So let's say we have f of x equals 10 log base 2 of x. So let's switch our x and y. So x equals 10 log base 2 of y. Okay, divide by 10, divide by 10. So x divided by 10 equals log base 2 of y. Well, now, what is our base here is 2. So I could say 2 to the power of x over 10, 2 to the power of log base 2 of y. Those undo each other. So we have 2 to the x over 10 equals y, and that's our inverse. So 2 to the x over 10 equals our inverse. All right. So let's say I ask you to determine if they're inverses. So if f of x equals 5 to the 4x and g of x equals 4 log base 5 of x, are they inverses? Well, you could try. Let's see it. Let's switch it around. So is x equal 5 to the 4y? Well, I want to undo this. So my base is 5. So 5 to the x equals, and it is an exponent, so I'm going to have to log base 5. So log base 5 of x equals log base 5 of 5 to the 4y. All right, so that reduces out. So we have log base 5 of x equals 4y. Divide by 4, divide by 4. So we could say no, that they are not equal. And I think we'll stop right there.